bending moment. This is generally related to the beam and the member on which this load is acting, shear force and bending moment, that is called as flexural member, in which the both bending and shear will be developed. So we learn beams in first year mechanics or mechanics तुम्ही केलंच नसेल diploma first year we have learned mechanics. So what is mechanics? What in mechanics? What is beam? Beam is the horizontal structural member subjected to transverse load to its longitudinal axis. Transverse load means what? Load which is perpendicular to the contact surface, contact plane. हा समजा तुमचा बीम असेल, हा बीम आहे, हे बीमची सेंट्रॉइडल ऍक्सिस आहे ही, आणि याला परपेंडिक्युलर हा जो लोड असतं, load which is perpendicular to the longitudinal axis, that is called as transverse load. Clear? Transverse load is a load which is perpendicular to the axis of member. And this transverse load, what it does, what it do, it will produce the bending of your beam like this one. This will produce bending of beam like this one. And because of that, there will be certain action develop in the beam that I will explain later. So the types of beam. Now types of beam is simply supported. Simply supported means what? One beam which is just rest on two support. Is that clear? This is simply supported beam for type 1. Now second is overhang beam. So overhang beam means what? The beam which is projected beyond support. So this is a hanging portion, so it is called as overhang beam. Then third one is cantilever beam. So whose one end is fixed and other end is free. This is fixed and other one is free. And the fourth one is continuous, in which the beam is rest on more than two support. So when it is supported more than two support, then it is called as continuous beam. So we have only three types, that is simply supported, overhang and cantilever, which are determinate beam. Clear? Determinate beam are the beam which are analyzed by the three condition of equilibrium. So the determinate beam which can be solved by three condition of equilibrium, summation of x is equal to 0, summation of fy is equal to 0, and summation of m is equal to 0. The beam which can be analyzed by the three condition of equilibrium is called determinate beam. Now supports. So every beam having various support. The first support is the roller support, which is display on this screen. This is the roller support, in which at the bottom of the support there are rollers. Clear? So roller, what it does, it allowed the horizontal motion. Roller allowed the horizontal motion. It also allowed the rotation. Roller is also allowed the rotation. Rotation is permitted. Rotation is allowed. Horizontal movement is allowed. Clear? So only one direction in which there is a restriction, that is perpendicular to the contact plane. So it has only one reaction in which there is a restriction. Reaction means restriction. So wherever there is a restriction, there will be a reaction. The roller support has only one reaction, which is always perpendicular to the contact surface. So here in this incline, you can see the surface is inclined like this and reaction is perpendicular to the contact plane. So roller support has only one reaction, which is always perpendicular to the contact plane. Now another type of support is hinge support. What hinge support? In hinge support, the horizontal as well as vertical movement are restricted. For example, you know that your mirror of your bike, you can rotate it about a certain point. You can rotate your mirror about that particular point, but you can't move your mirror in this direction or in upward direction. So their movement in horizontal and vertical direction is restricted. it can be rotated about its own axis. So rotation is permitted, rotation is allowed, rotation is permitted. But there are two restrictions, that is Rx and Ry. So in hinge support has restriction to movement in x direction, therefore it has two reaction. Clear? Hinge support has two reaction. Now the fixed support, if we are welded any point, any member, it does not permit to move in horizontal direction, it does not permit to move in vertical direction, even though the rotation is also restricted. Rotation is also restricted. So it has three reaction. Fixed support has three reaction, that is Rx, Ry and moment. Clear? We can write Rx, Ry and moment also. So either VA, HA or moment, or Rx, Ry or moment. So fixed support has three reactions. Now load. This we all learn in first year diploma or in even MOS and TOS also. So there are three types of the load, that is point load. The load which is acted at a particular point is called as point load. In this particular, you can see that this load is acting at a particular point. So this is your point load W. It is acting, suppose this is A point, this is B point. So this will be act at a particular C point. So this is called as a point load. Clear? Now uniformly distributed load. So the load which is uniformly spread throughout its length. So for example, you can see your mobile, the mobile having a common thickness, and this mobile is supposed to be n number of length long. So it's supposed to be 10 meter long. So for every 1 meter, the length of that mobile is uniform or constant. Or you can see the beam above you. If you see the beam, the cross section of the beam in your home, if you see up, so the cross section of the beam is uniform. And for per every 1 meter, for every 1 meter, if you cut that beam, we'll get an equal weight. So such load which is uniformly spread over the length of the beam, that is called as uniformly distributed load. The load which is uniformly spread over the length of the beam is called as uniformly distributed load, UDL. So you can show UDL like this, or UDL can be represented as a rectangular loading. UDL can be represented as a rectangular loading like this. This is your UDL. Clear? So like this you can represent UDL, and area of this rectangular loading, UDL is also called as rectangular loading. UDL is also called as rectangular loading, and this area of rectangle loading diagram will give us equivalent point load. So here this is a rectangle having the height W and length L. So rectangle area is length into height. So W into L will give us equivalent point load. WE, that is equivalent point load of this, is W into L, length into width. So length into this height, W into L is the equivalent point load. And we know that the CG of rectangle will be act at L by 2. Center of a rectangle will be act at L by 2. So here the equivalent point load which is acting in this particular member will be act at a distance L by 2. Here somewhere. This is equivalent point load WE, which is act at L by 2. Clear? So like this you can convert UDL to equivalent point load also. and equivalent point load is nothing but W into L. Like this you can convert. Now the next loading is uniformly varying load. The intensity of the loading increase or decrease at a constant rate is called as uniformly varying load or triangular loading. See here, it is increasing uniformly, or if you show the figure like this one, here it is decreasing uniformly. So this is your uniformly varying load. Load is increasing or decreasing is called as uniformly varying load. Clear? Now it's a triangular shape. So area of loading diagram, as I told above, the area of loading diagram will give us equivalent point load. Now it's a triangle. Area of triangle is half. Base means length and height means W. This is your height, which is W, and length is L. So like this, you will get equivalent point load WE is equal to WL by 2. Clear? And the centroid of this rectangle and the centroid of this rectangular figure is at somewhere here. And you know that the centroid of a triangle, centroid of a triangle will be at from this vertical face. ये जो vertical face है, from this vertical face, it is L by 3. Vertical face say L by 3. If this is L by 3 and total length is L, so from this apex, it is 2L by 3. Clear? Like this, you can get the equivalent point load. Now here in second case, the vertical distance on the left side, so here it is 2L, sorry. From this side, it is L by 3. Clear? Is that clear? Various types of loading. These are the various types of loading which we have to convert while solving the numerical. So there are three types of the point load. One is point load, which is acting at a particular point. Second is uniformly distributed load, the load which is uniformly spread over a length of the member. Third is uniformly varying load, the load which is uniformly or linearly increase or decrease along the length of the member is called as uniformly varying load or triangular load. And equivalent point load will be the area of loading diagram. Clear? Equivalent point load is the area of a loading diagram. If there is rectangle, so for rectangle is the area of rectangle width into height, and for triangle, area of the triangle is half base into height. And there CG, rectangle CG is L by 2 and triangular CG is L by 3 or 2L by 3. Like this, you can convert your UDL. Now next, is it clear to all the type of beam, type of supports and type of loading? Clear? Please reply.
Okay.